I've recapped the first keyboard and installed the LED slider kit. I've also rebuilt the power supply, and I removed the damaged section of wire and reconnected the existing wire, so it's just a few inches shorter than it was before, but it's still plenty long. Right now I'm in the process of changing the key bushings. The key bed is filled with dust, so I'm going to clean that out. I've also taken the touch sensor bar off down here, and I've installed a new touch sensor strip. The old one, I tested it out and it was dead. So while I had the access to it, I rebuilt it. And after I'm done changing the bushings, I'll reinstall it. I will clean the key contacts and put that board back into the key bed so we can have a full keyboard assembly, and then we can connect these boards and bench test this synthesizer to see what other issues there might be. I've cleaned the bottom of the key bed out, and since I have the keyboard electronics board with the little contacts for each key removed, it provided a good opportunity to actually remove the bus boards, so I can the bus bars, so I can clean them better. So there's screws here. They're the same type of screws that are used to hold the keys in on top of the keyboard, and I've removed them. And this actually releases the bus bars. So now I turn it over, and previously they'd be hanging down here, and now I've removed them so I can clean them really well. You can see that they, if this focuses, they should be shiny. They're gold plated and they should be shiny, but grime and stuff builds up on them over time, and it prevents the keys from making good contact, and it causes keys not to trigger, keys to trigger multiple times. So we'll definitely clean this up really good and then reinstall them. We'll put the new bushings on. I've already leveled the key bed, so we'll put new bushings on and reassemble the keyboard. I have another video where I restored a Pro DGX where I show you in greater detail how to get the keyboard apart and install new bushings and clean these bus bars. So look for that video if you're interested in more info on that. But I'm going to clean this up and put the keyboard back together, and then we should be ready to test the unit on the bench. So you can compare, here's the cleaned bus bar compared to the original dirty bus bar. So that's going to make a big difference on this keyboard. In addition to cleaning the bus bar, since I have easy access to it, I've also cleaned the individual wires for each of the keys on the keyboard electronics board. And I noticed a reason why if you recall, the keyboard electronics board was kind of just floating loose and the key contacts couldn't reach the bus bar. That's because all of the standoffs that are used to mount this board to the key bed, every single one of them was broken. Some of them are missing both edges, and some are just missing one. But we're going to replace these all with new ones, so the keyboard electronics board can firmly attach to the key bed and won't come off again. So, with the exception of the power supply, I've reconnected all the boards of this synthesizer. The power supply, probably should reinstall it into the case for further work here, because basically there's mains voltages coming on these wires, and that's kind of dangerous, but I know what I'm doing, so it's okay. I plugged the power supply in, and I tested on this connector. The voltages will vary they'll change when I connect this to the board, but I wanted to make sure that the power supply at least was roughly okay. So I tested the different voltage rails by probing the Molex connectors through the housing there. Black is ground, red is plus 15, black is ground, purple is minus 15, and orange is plus 5. And the voltages are correct, and power supply is not exploding, so I can connect it now to the keyboard here. I'll also plug an amp into the into the jack. This is the low output. The high output was an RCA jack that wouldn't be so easy to remove from the case. And then we'll fire this up. I haven't hooked up the power to the LED sliders, and I haven't hooked up the touch sensor, although I made a connection there so it can plug in. But I will connect the power and we'll fire this up and see if it works. So I've connected the power. One thing I also had to do was connect the green wire, which is the high output, to that resistor which feeds down to the low output. But I've connected the power and I've turned on a voice. I have glide very high, so let me turn it. I'll have to track down what that noise is. It could be, it could just be the way that this is connected to the amp. But we are getting sounds out of it, so now what I'm going to do is I'm going to go through and I'm going to test everything and see if there's any other electronic issues that need to be repaired on this before we put it back into the keyboard. I'm also going to connect the touch sensor and test this touch sensor effect before I put the boards back in. But the recap and changing of the sliders has brought this to life, and we're going to just make sure that it's functioning properly, and then we'll calibrate it and pop the boards back in the case. So I've had a chance to go over this and look for a first pass of some issues that need to be addressed. So I've got tuba turned on now. And it sounds like it's an octave or two too low. All the voices actually sound transposed down some. So here's flute. Actually, this is flute. And that doesn't sound right. And the other thing I noticed, I'll put on a voice and I'll transpose it up so we can... Okay. So this is the keyboard. This is the low C here. So the keys are actually, there's 4 bus bars, one for each octave. So there's 3 octaves with 12 keys, and then the high C. And it seems that the keys are the order is reversed. So the key is this is should be the low key for that octave, when in fact it's the high key. So this keyboard electronics board sends a key code that says which key is pressed through the ribbon cable to the envelope generator board and the waveform generator board. So we're going to need to take a look and make sure that that code is being transmitted correctly, and if it's not, we can correct that, and if it is, we can figure out why it's not being processed correctly. The other thing is the touch sensor bar. I've installed the touch sensor bar, or I've connected the touch sensor bar, and I fiddled with the touch sensor sensitivity trimmer, and I can't get any touch sensor effects to work. So all the touch sensor effects aren't working. What I can get working on this board, so I know that the board itself has some life to it, is, sorry, I'm trying to figure out which voice I'm picking, is the repeat. So this is upside down. So repeat works, and this LFO here for the vibrato and repeat speed, that works. So I am going to try to figure out why the touch sensor effects aren't working, and that's going to be the first pass of repairs and investigations that I make to this keyboard, and I'll let you know what I find. One thing that I do when I restore a synthesizer is I go through with a thermal imaging camera just to make sure that everything, nothing is putting out excessive heat that shouldn't be putting out excessive heat. I mean, one thing that I would expect to be hot would be these diodes in the power supply. They're running at about 78 degrees. I'd expect the regulators here and the transistors on the heatsink, the transistors on the heatsink to be hot, and they are. But they're not like outrageously hot. I mean, I've seen an OB8 recently that was running at about 160 degrees on its bridge rectifiers, 160 degrees Celsius. But one thing that I noticed over here is a resistor here that's abnormally hot. And then also I noticed the resistive element of the touch sensor pot is also hot, and it shouldn't be. So, at least I don't think it should be. So I'm going to use that as a clue in troubleshooting why the touch sensor might not be working. So again, it's that resistor right there below this trim pot, although it's next to the tune trim pot, not the touch sensor trim pot. So that's just one piece of information that I can use. I'm not going to make any guesses based off that, but when I do some further research, it's good to know. So it looks like the reason this is not tracking in the correct direction and also is out of tune, it looks like there's a bad op amp in the digital to analog converter. So this is set up as a differential amplifier, and this is the output from the control from the resistor network that does the D to A conversion. And so when I do low C, I get 2 volts, and as I work my way up, the voltage drops to about half a volt on B, and then the positive input to the op amp is 5 volts, and then the output is 2 on the low C, down to about 1. So so the op amp appears to be bad. I'm going to change the op amp and we'll see if that fixes the problem. Replace the op amp in the digital to analog section right there on board A, and now the notes go in the right direction. So they go higher in pitch as you go up the keyboard instead of lower in pitch. So now I'm going to see if I can get the keyboard to tune. Previously it couldn't, and this is a probable explanation for why it wouldn't tune. So I'll get it in tune and then check back with you. The next item that I need to repair is the touch sensor effects aren't working. The old touch sensor tested bad, and I replaced it with a new touch sensor, but the touch sensor effects still aren't working, and I've confirmed that the new touch sensor is good. So the touch sensor, when you apply pressure to it on this op amp here, on the output of that, it generates a voltage from 0 to 15 volts depending on how hard you press. So while I was pressing with various pressures, I tested the output of that, and it was 0 constantly. And I took a look at the input, and that was also 0. And the input comes from this transistor here, which is fed through the touch sensor, which connector to the wire to the touch sensor is there. So you see this trace comes along here and goes into the base of that, the emitter of that transistor. And it looks like there's a resistor that is soldered there, and this side of the resistor came up. It wasn't soldered well to the board. I don't know why the resistor was there in the first place. Maybe it was an attempt to fix the touch sensor since the touch sensor strip was bad. But basically there's a break there in the circuitry for the touch sensor, so it can't work. So what I'm going to do is I'm going to remove that resistor, and I'm going to repair that trace with a jumper wire, and then we'll see if that fixes the touch sensor effects. I've removed the resistor that was dangling off the board, and I put a jumper wire connecting the cut trace there. And now when we try the touch sensor effects, they're working great. So now I need to go through the keyboard again and make sure that all the voices sound correctly, all of the different touch sensor effects individually are working properly, and see if there's any other issues that need to be repaired while we have the boards out. Correcting this broken trace resolved the touch sensor issues, and changing this op amp corrected the issue of the keys going in the reverse direction, that the keyboard was several octaves too low, and also it couldn't tune. Now it can be tuned, and it does scale correctly over all 5 octaves. So I'll take another look and let you know if there's any other issues that we need to resolve. Also, I've gone back over the board with a thermal camera, and previously the touch sensitivity slider resistive track was running hot, and now it's not. This resistor here was running hotter than it is now. Since we corrected the tracking, it's running at a more reasonable temperature. It's still warm, but it's within reason. So those were clues as to where there were problems. I went through the touch sensor effects, and some of them are working and some of them aren't. So this is vibrato, which is working. This is volume, or this is volume. That's working. This is brilliance. That's not working. This is growl, and that's not working. This is wow, and that's not working. And this is pitch bend, and that is working. So these are what we're going to track down next. So we're going to take a look at why these touch sensor effects aren't working. So there's 3 that aren't working. I've marked the ones that are okay, but wow, growl, and brilliance all don't work. And all of these are handled off board on different boards. So the first one is the growl and the brilliance come in here on board B and come to this op amp. The op amp basically inverts the ADSR signal to a negative going envelope, because the VCF responds to negative going control voltages, whereas the VCA responds to positive control voltages. The op amps, we've already replaced one, and on other ones I've had to replace other op amps. These op amps are sketchy to begin with. So let's take a look and see if this one is working correctly. So this is Z6 on board B. Board B is this one, and there's only one op amp there. So let's take a look at it. Pin 6 is the output, and again we'd expect it to be 0, and then when the envelope shows up, it'll go negative. So let's take a look at pin 6. And it's negative 13 volts, and whether I press a note or the touch sensor, that thing is not moving. So let's take a look at the inputs. The non-inverting input here is directly connected to ground. So let's take a look at that. That's pin 3. That's a negative 13 volts. So and it should be ground. So this op amp is bad, and it's causing the wrong control voltage to be passed to the filter. So that's something that we're definitely going to need to replace. And hopefully that will resolve these two touch sensor effects. The wow comes in on board C, and it affects the resonance of the filter. So actually I'm going to want to change out this op amp before I spend much time troubleshooting this, because if the control voltage of the filter is wrong, then the resonance control probably, that would be a good explanation why that wouldn't be working. But let's make sure that the right signal is being passed here. Basically, when wow is turned on, when wow is turned off, we have 0 volts being passed in on this cable. When wow is on, we should have 5 volts passed in. So that's pin 13 on this connector. Let me find pin 13. So I have wow off now, and I have ground. I'm going to turn wow on, and I have 5 volts being passed through. And I can take a look at the effect on these transistors, the input to the resonator on the filter. I have buzz bassoon on, so that's going to use full maximum resonance. So that comes off this line, pin 9 of the ROM, comes here and goes through this pair of transistors. So I should be for output. I should be looking on the collector of Q5. Q5 is here. Collector is in the middle. So that does seem to be alive. So I'm going to go ahead and change this op amp first, and we'll see what problems that resolves. I've changed the op amp on the envelope generator board, and now let's test those bad touch sensor effects. So the first one that we're going to test is the brilliance. So we definitely hear that filter opening up with that effect. The next one is going to be growl. And we definitely hear the growl effect. And the last one is wow. And we definitely hear that resonance effect coming in with the wow. So now all the touch sensor effects are working correctly. And I'm just going to run through the voices and make sure that they all sound correct. And if that's the case, then we've completed the restoration. We need to put everything back, but we'll have got this one working all the way. So I'll run through the voices, and I might probe different points to make sure various resonators are working like they should, and all the different elements in the signal path that get switched on and off with the ROMs. I can probe them with the oscilloscope and make sure that the waveforms are what the manual would tell us we should be looking for at the various different test points on the different voices. So I'm going to do that with a few voices, and I'm going to listen to all the voices and make sure that they sound good, and then I'll report back.